Gargantuan sunspot 15 Earths wide shoots powerful X-class flare towards our Earth, triggering radio blackouts. According to space weather and Daisy Dobrijevic, a sunspot so big it rivals the gigantic sunspot responsible for the Gargantuan event that happened in 1859 has unleashed another X-class solar flare, triggering radio blackouts on our Earth. AR 3664 is no ordinary sunspot. The behemoth dark patch on the sun's surface has ballooned in recent days, becoming one of the largest and most active sunspots seen this solar cycle. AR 3664 garnered the attention of scientists earlier this week as the National Oceanic and Atmospheric Administration NOAA Space Weather Prediction Center issued a warning of increased solar flare risk from the solar giant on May 7th, on Tuesday, that is. And Gargantuan sunspot that spit out the stronger solar flare in 6 years, now pointing almost directly at Earth, they said. Colossal Martian sunspot is so big it was seen from Mars, now it's facing Earth. Region 3664 has grown considerably and has become much more magnetically complex, NOAA SWPC reports. This has led to increased solar flare probabilities over the next several days. The giant sunspot has more than lived up to its expectations, firing out countless powerful solar flares in recent days, including a colossal X-class solar flare this morning, May 9, peaking at 5:13 a.m. EDT. Solar flares are eruptions from the sun's surface that emit intense bursts of electromagnetic radiation. They are categorized by size into lettering groups, with X-class being the most powerful. Then there are M-class flares that are 10 times less powerful than the X-class flares, followed by C-class flares, which are 10 times weaker than the M-class flares. B-class are 10 times weaker than C-class flares, and finally the A-class flares, which are 10 times weaker than B-class flares and have no noticeable consequences on our Earth. Within each class, numbers from 1 to 10 and beyond for X-class flares describe a flare's relative strength. The X-class flare this morning clocked at X 2.25 according to space weather, measured by NASA's GOES-16 satellite. Powerful solar flares like the one observed this morning can cause shortwave radio blackouts on the sunlit side of our Earth at the time of the eruption. As such, the X-flare this morning caused shortwave radio blackouts across Europe and Africa, and the radio blackouts are due to the strong pulse of X-rays and extreme ultraviolet radiation emitted during the eruption. The radiation travels towards Earth at the speed of light and ionizes and gives electric charge to the top of the Earth's atmosphere. Note, these ionized X-rays are not to be confused with coronal mass ejection CMEs, by which plasma and magnetic fields erupt from the sun, traveling at slower speeds, often taking several days to reach our Earth. This ionization causes a higher density environment for the high-frequency shortwave radio signals to navigate through in order to support communication over long distances. The radio waves that interact with electrons in the ionized layers lose energy due to more frequent collisions, and this can lead to radio signals becoming degraded or completely absorbed, according to NOAA's Space Weather Prediction Center. Sunspot visible from our Earth, sprawling out at almost 124,000 miles, that's 200,000 kilometers from end to end. The sunspot AR 3664 is currently 15 times wider than our home planet, according to space weather. It's so big that it can be seen from Earth without the need of magnification. And if you still have a pair of solar eclipse glasses lying around after April 8th's total solar eclipse in the US, you can use them to safely observe the sun and see the mammoth sunspot across the solar disk. But remember, never look at the sun without appropriate solar protection. You can find out how to safely observe the sun with the helpful solar observation guide. This rivals Carrington Sunspot. The vast size of Sunspot AR3664 rivals the Carrington event Sunspot of 1859, as depicted in the image from Space Weather. Carrington Sunspot is known for its explosive rampage between August and September 1859, during which it fired off a series of powerful solar flares and CMEs, resulting in major geomagnetic storms that ignited telegraph offices and triggered auroras as close to the equator as Cuba and Hawaii. Although studies suggest Carrington-class solar storms occur every 40 to 60 years or so, and we are long overdue, there is no evidence that any CMEs currently en route from previous solar eruptions this week could cause a new Carrington event, according to Space Weather. Scientists are keeping a close eye, of course, on this ever-growing sunspot while it continues to face our Earth. This is by Daisy Dobrijevic on Live Science. Please leave your comments. Thank you for your support. My Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.